Did you know? 95% of factories in Vietnam are using wet steam without realizing it, causing businesses to waste around 100 million Vietnamese dong each year just because the steam isn't dry. The cause isn't the operators. The real issue lies in the boiler's design, specifically the small steam drum and water pipes, along with improper feedwater arrangement. Most boilers on the market experience this problem. So what are the specific causes? Let's take a closer look at each factor. Because number one, this is a typical design of a two-drum water tube boiler. The lower drum holds water, the upper drum holds both water and steam. Evaporation takes place in this upper drum. At the same time, feedwater is supplied here. The steam drum is often too small. For a 10-ton boiler, the steam drum diameter is only about 1 meter to 1.2 meters. Yet this is the most critical part, the chamber that stores saturated steam for the system. In theory, an ideal steam drum should have 3 functional zones. The boiling zone, where water vigorously boils, forming bubbles. The steam water separation zone in the middle. The saturated steam zone at the top. In reality, because the drum volume is too small, there isn't enough space for the steam zone. As a result, only 2 zones remain, the boiling zone and the separation zone. The saturated steam zone disappears. Therefore, the steam taken out is not pure dry steam. Cause number 2, improper feedwater design. Many boilers install the feedwater pipe horizontally across the waterline or distributed above. Meanwhile, the steam flow rises upward. These horizontal jets of feedwater cut across the rising steam, dragging countless small water droplets along. The result? The steam supplied to the system becomes severely wet. When the feedwater pump operates, boiler pressure drops significantly. This is a clear sign that the water stream is cutting across the steam flow, reducing both pressure and steam temperature. So what happens if your boiler is delivering wet steam? First, reduced heat transfer efficiency. If the steam contains 5% moisture, about 3.7% of its energy is lost. Second, equipment wears out quickly. The tiny water droplets will damage the equipment. Third, product quality issues. In the textile industry, it causes fabric stains during ironing. In food processing, it may carry impurities that compromise product quality. So how can you know if your boiler is producing wet steam? There are 2 signs and 1 direct inspection. First sign, whenever the feedwater pump runs, steam pressure drops. Second sign, measured steam temperature is lower than the theoretical saturation table. For example, at an absolute pressure of 9 bar, the standard saturation temperature is 175.4 degrees Celsius. But if your actual reading is only around 172 degrees Celsius, the steam is definitely wet. Third sign, when opening the steam drum, if you see the feedwater pipe lying horizontally at the waterline, not separated from the rising steam flow, that is solid evidence you're using wet steam. Some companies thought that simply installing a mesh screen at the steam outlet would solve the problem. But in reality, this is only temporary and not an effective solution. Other boiler manufacturers tried adding steam headers to slow down the flow, hoping to trap water droplets. But this only works for larger droplets. The tiny ones remain almost impossible to remove. So what's the true permanent solution? There are 3 fundamental approaches. Solution 1, design a sufficiently large steam drum. Ensure the drum can form all 3 distinct zones: boiling, steam water separation, and dry saturated steam. Solution 2, proper feedwater design. Make sure the feedwater does not cut across the rising steam flow, maintaining separation between water and steam. Solution 3, install a steam separator at the steam outlet. This is the easiest and most cost-effective solution, yet highly efficient in producing dry steam. A steam separator works by removing moisture through centrifugal force and flow redirection. When wet steam enters, thanks to its special internal geometry, the steam spins in a helical path, losing kinetic energy. Water droplets are flung outward, collected, and drained back to the feedwater tank or deaerator via a drain valve or steam trap. The result, pure dry steam is delivered to the end-use equipment. This is a mechanical and physical process. No electricity, no energy consumption, stable operation, and up to 99% separation efficiency. If you found this video useful, don't forget to like, share, and subscribe to support DIVI's channel. Thank you, and see you again in the next video.